Let's do example problem 10 on page 32 in chapter 2. Here is the problem in the book. It says, falling from a tower, suppose that a ball is dropped with the initial velocity equals 0 from a tower 70 meters high. How far will the ball have fallen after 1 second, 2 seconds, and 3 seconds? So I've got it done here. So let's first of all set it up with given and find. And so here's our initial position of 70 meters above the ground, and our initial velocity is 0. And then at 1 second, so this is t equals 1, t equals 2, t equals 3 seconds. We want to know what is the delta y. How much did we fall? How far did we fall down in these times? Now to solve it, what I did is I chose one of the kinematic equations. And I looked at what it is I was trying to find, delta y. So it has to have delta y in it. But notice that I'm not given the final velocity, and I'm not trying to find it. So I usually look for what I don't have and what I'm not trying to find. That's no on that little chart. So this worked out to be the third kinematic equation on the chart. And it's delta y equals v naught t plus 1f at squared. Now the initial velocity is 0, so this term goes away. And so delta y equals 1/2 the acceleration, which is negative 9.8 meters per second squared, times time squared. And notice that when I do the arithmetic, here's 1 divided by 2's, and then divide that into 9.8. You get negative 4.9 meters. And then at 2 seconds, we just do the same thing, but now it's 2 seconds. We have to square it, and then divide by 2, and then multiply by 9.8. You get negative 19.6 meters. And so that means that it's fallen 19.6 meters below where it started. Right? It's asking for how much it changed its position. It dropped, that's what the negative means, 19.6 meters. And then we just do the same thing at 3 seconds, and we drop 44 meters below where it started. Now, if you look at the book solution, we get the same answers, but I don't like their answers. Let's see. The book says, okay, y1 is 4.9, y2 is 19.6, y3 is 44.1 meters. But I like to make down negative and up positive, and I found that students like that. And also, I don't like the fact that, see, they didn't state it in here, but you're making the origin, you're saying y naught equals 0 at 70 meters of height above the ground, and you're making down positive. So they make a lot of unnecessary assumptions here. And so I'm just showing you this because I want you to know that I do diverge from the book a little bit. Based on what they asked, this ball that's dropped 4.9 meters from where it started. It dropped 19.6 meters. It dropped 44.1 meters from where it started. This is better. Okay, what I did is better than the book. I should write my own book. Okay. Now, if you do it the way the book does it, I'm not going to mark it wrong, but it might be a little bit confusing. So if you do it my way, and your answers are kind of the same as the book, but the sign is different, that's okay. You can put a star next to it. Okay, especially if you understand. Okay, make sense? Any questions? Okay, that is all.